to element number 8 of the OSHA PSM system. This element will discuss the mechanical integrity. The mechanical integrity is considered to be one of the most important elements in the OSHA PSM system, if not the most important, and also it is the most violated element of the PSM standard. We will know this later on. So let's start by defining what is meant by mechanical integrity. Mechanical integrity is the management of critical process equipment to ensure it is designed and installed correctly. Also, to ensure that it is operating and maintained properly. Okay? So, the mechanical integrity is the mechanism on how to manage the critical process equipment. And the initiative for mechanical integrity was raised by American Petroleum Institute through the release of major standards and recommended practices covering this region. Okay? So mechanical integrity aims at ensuring that equipment and or assets are designed, fabricated, installed, operated, and maintained in a way that provides desired performance in a safe, environmentally protected, and reliable fashion. So what is reliability? Reliability is the ability to perform as required without any type of failure for a given interval under given conditions. Okay, we know from element number 3 the definition of failure, which is the loss of ability as required. Okay, so as we mentioned, that the godfather for mechanical integrity is the American Petroleum Institute. On 1958, API started the initiative for mechanical integrity by releasing the API 510, which is the code for pressure vessel inspection. There is also a book in the course resources that I will provide, and it contains most of the API release standards, codes, recommended practices, and so on, which are relevant to mechanical integrity. Okay, so from the definition, we need to know what is criticality. Criticality is the priority rank of failure mode based on some assessment criteria such as operational and HSE consequences and the likelihood, of course, of failure occurrence. If you recall, when we studied on element number 3, the failure mode and effect analysis, the high RPN numbers states or reflects a certain mood or a certain aspect of criticality. Okay? In order to define critical process equipment, we need to perform a criticality analysis. And criticality analysis is a procedure by which each potential failure mode is ranked according to the combined influence of severity and probability of occurrence. Okay? So the best way to perform a criticality analysis is by doing FEMICA, or failure mode and effect and criticality analysis. If you recall, we said that don't forget that we will return to FEMICA later on. Okay, so now is the time to know what is FEMICA. FEMICA is a simple extension to FEMIA, okay, where the RPN is quantified and reflected on a risk criticality matrix upon which the criticality of equipment or element is identified and ranked. Okay, so you have here the risk criteria. If you remember, we have the RPN numbers. If we have a failure mode with a high RPN number according to the risk criteria, then this item or this element will be classified or ranked as critical. And according to the aspect it covers, it could be process critical, environmentally critical, or safety critical. Okay. The best standard that you can refer to regarding FEMICA is the British Standard 5760-5. Okay? And also, I need to highlight that you need to refer to the basis of risk quantification, RPN, then criticality matrix, according to what the management says. Okay? And there are, of course, many ways that you can calculate the RPN, but I need you to understand the basis of classification or the basis of ranking. Okay? So let's move on. So, what are safety critical elements? Safety critical element is such part or parts of the installation, including computer programs or any parts thereof, number 1, the failure of which could cause or contribute substantially, or a purpose of which is to prevent or limit the effects of a major disaster. So this element or this part, if it fails, it may lead or it may contribute to a major accident, or if it fails, then it will lead to this. Okay, this consequence, I mean, of course, or this element could prevent or limit the effect of the disaster. And from the definition, we can conclude that safety critical elements could be preventive or mitigative. And we will know this later on. What is the importance of safety critical elements? Number 1, safety critical elements set the baseline for how the operational conditions should be established in order to maintain the process within the safe operating or safe working envelope. Number 2, safety critical elements establish the performance standards against which the performance of the control can be monitored and measured. Okay? So, what are the safety critical elements performance standards? They are an agreed standard that is set and against which actual performance is measured and judged. There are various models and methodologies used for setting the safety critical element performance standards, but the most famous one is the FARSI approach. And the FARSI is an acronym for functionality, availability, reliability, survivability, and interdependency. We will know them furthermore on the next few slides. What is the FARSI approach? It is a methodical way for describing and understanding the performance standards of various safety critical elements. It provides a reference for critical issues to address in material of construction, testing, maintenance, repair, and operational variation situations. Okay, so let's know more about FARSI approach. We have here the functionality, availability, reliability, survivability, interdependency. Regarding the functionality is related to the task that any particular element is intended to perform. Okay, the safety critical element is thus defined by what it is supposed to do, to what standard it is to perform, and how that can be measured. For example, a storage tank, you have here a storage tank. The design pressure, of course, will be affected if the material of the tank degrades. Okay, so to ensure the integrity of the tank, there will be a standard for which a degree of corrosion that is tolerated can be known. Okay, regarding the availability, it defines the time for which the safety critical element will be actually operational or available to be operational. Okay, for example, we have a pump required to remove material in a shutdown. Okay, and this pump will work only if the power supply to it is maintained. Ideally, a safety related function should be available 100% of the time, but there is always a possibility that a power failure may take place. Okay, quantified risk assessment here could be used to determine the downtime for such equipment and set a design target for it. For example, a 99% of the time it will be operational, but in operational terms, if the function is required during the remaining 1% of the time of the function, okay, so you will be needing a backup power source such as a UPS, and the UPS shouldn't be only one battery. You will have to have another battery, which is a backup battery for this UPS. So this is what is meant by the availability. It means that you must ensure that the equipment will be available all the time. Okay, let's move on to reliability. For a safety critical element function to work, it needs to be reliable. When the function is required, it has to work. Okay? And reliability is often determined by cell determination or safety integrity level determination studies, and this is related to the trend of functional safety. Okay, regarding the survivability, it describes here the properties and characteristics of the safety critical element when and after it is expressed to an emergency situation. Okay, is it designed to endure fire for a specific period of time, such as fire-rated doors? And this is just an example, or it will fail. And the last element of the FARSI approach will be the interdependency. And the interdependency defines the other relevant safety critical elements and factors on which the safety critical element being examined relies. Okay? Okay, enough of this long introduction. Let's go directly to the application of this element. This element applies to pressure vessels and storage tanks. It applies also to piping systems, including valves. It applies to relief and vent systems. It applies also to emergency shutdown systems. It applies to controls and pumps. And regarding the controls, okay, so what are the OSHA PSM mechanical integrity elements? Okay, we have here 5 major elements. They are concluded as follows. We have the procedures, training, inspection and tests, equipment deficiencies, and quality assurance. Regarding the procedures, OSHA mandates to develop and implement written procedures to maintain the ongoing integrity of process equipment. Example for that is preventive maintenance procedures, inspection procedures, pigging procedures, corrosion monitoring procedures, and so on. Okay? Regarding the training, OSHA mandates training for process maintenance activities for employees involved in maintaining the ongoing integrity of process equipment. And the training should include an overview of the process and its hazards and in the procedures applicable to the employee's job tasks in order to assure that the employees can perform the job tasks in a safe manner. Regarding the inspection and testing of process equipment, OSHA mandates that the inspection and testing shall follow recognized and generally accepted good engineering practices. Also, OSHA mandates that the frequency shall be consistent with applicable manufacturer recommendations and the good engineering practices. And regarding the frequency, it can be increased if determined to be necessary by prior operating experience. Okay? And at last, OSHA mandates that inspection and testing, of course, should be documented. Okay, the documentation, of course, shall identify the date of inspection or test and the name of the person who performed the inspection and the serial number of the equipment. Okay, and the description of the inspection test and the results of the inspection, the standard or code or recommended practice upon which the inspection and testing was based on. Okay, regarding the equipment deficiencies, OSHA mandates that the employer shall correct deficiencies in equipment that are outside acceptable limits. Okay, the correction or rectification of deficiencies shall be before further use or in a safe and timely manner when necessary means are taken to assure proper or safe operation. And regarding the quality assurance, we have two phases. The construction phase, upon which the employer shall assure that equipment as it is fabricated is suitable for the process application for which they will be used, which is also known as the fitness for service. And regarding the operation phase, we should know that checks and inspections to assure that equipment is installed properly and consistent with design specifications and with manufacturer instructions should be done. Okay? And also, we should make sure that maintenance materials, spare parts on the equipment are suitable for the process application for which they will be used. Okay? So I believe now we have concluded the OSHA PSM mechanical integrity element. It's a very important one and it is the most violated one as we have mentioned in the beginning of this element. Stay tuned for element number 9. So hello and welcome to element number 9 of the OSHA PSM system. This element will discuss the hot work permit. Okay, so let's start by defining what is the hot work. The hot work is a process that includes riveting, welding, flame cutting, or other fire or spark producing operation. Okay, so this is a solid definition of hot work. Okay, let's move on to what OSHA mandates regarding the hot works. OSHA mandate to issue a hot work permit for covered or nearby areas of the process. The hot work permit should include the date of authorization for hot work, and it should identify the object on which the hot work is to be performed, and at last, the permit should be kept on file till the completion of hot work operation. Moreover, OSHA mandates to document that fire prevention and protection requirements are applied before starting up the hot work operations, and these requirements are enlisted in detail in the standard 1910.252. It's an OSHA standard, again, 1910.252. I'm going to list a summary of these requirements. We cannot go into much detail regarding the hot work requirements. I'm just telling you what the OSHA PSM mandates regarding the hot work permit. So, regarding the fire prevention and protection requirements, OSHA hot work standard classified these requirements into 4 sections. The first section will be about the basic precautions. The second one will be about the specific or special precautions. The third one will be about the welding and cutting containers. And the fourth one will be regarding the confined space. I'm going to address the basic precautions and the headers of the special precautions. Okay, regarding the basic precautions, OSHA hot work standard says that if the weld or cut object cannot be moved, then all movable fire hazards in the vicinity shall be taken to a safe place. If this is not feasible, then you should either confine the heat or spark or slag, or you should protect the immovable fire hazards. If neither one or two are applicable or feasible, then the hot work should not be allowed. Okay? Regarding the special precautions, I will give you the headers. They are related to combustible materials, fire extinguishers, fire watchers, authorization, floors, prohibited areas, relocation of combustibles, ducts and conveyor system, combustible walls, non-combustible walls, combustible cover, pipes, management precautions, supervisor precautions, and fire prevention precautions. All of these precautions are enlisted with great amount of detail in the standard 1910.252. I will attach, of course, this standard in the course reference material. You should take a look at it. Okay? At last, I'm going to show you a typical form of hot work permit compliant with OSHA hot work standard. As you can see from here, we have the precautions which are enlisted in the standard, and they are using the checklist format in order to facilitate applying these precautions. I will attach also this permit in the course reference material. Okay. At last, I thank you for your attention and stay tuned for element number 10. Hello and welcome to element number 10 of OSHA PSM system. This element will discuss the management of change. So let's start by defining the categories of change. We have changes relevant to process chemicals. We have changes relevant to technology. We have changes relevant to equipment. We have changes relevant to procedures. And at last, we have changes relevant to the facility affecting a process. And here OSHA says that the employer must develop and implement procedures for managing all of these categories. Okay? And before implementing any type of change in the facility, the management of change procedures shall assure the following considerations. Number 1, it shall assure the technical basis of the change. It also shall consider the impact of that change on health and safety. Moreover, it shall consider the modifications of operating procedures that will be a result due to this change. Also, it shall consider necessary time and period for this change, and at last, it shall consider the authorization requirements for the proposed change, and this is done according to the level and magnitude of the change. All of changes must be procedurized, okay? All of the changes must be submitted or must be relevant to a specific procedure. Okay, what about employee involvement? Okay, let me just zoom in. Employees involved in the process and employees involved in the maintenance and contractors whose tasks are affected by the change must be informed of the change and trained in the change before starting up the process. And this is very important and very critical. They have to be addressed about the change and they have to be trained if training is required regarding this change. Okay, so what about updates? If the change will lead to a modification in the process safety information, or if it leads to a change in the operating procedures, then the operating procedures and the PSI should be reviewed and updated. Okay, guys, I thank you all for your attention. Stay tuned for element number 11. Hello and welcome to element number 11 of OSHA PSM system. This element will address the incident investigation. But before we start, let's define the domino effect. And by domino effect, we mean that accidents or incidents do not just happen out of the sudden. On the contrary, they are a series of interconnected events that accumulate all together to give rise to the event, just like the pieces of dominoes falling respectively. Okay? Moreover, if you recall on element 3 regarding the fault tree analysis, we said that fault tree analysis do not enable the domino effect. And this is right because fault tree analysis only gives you the options of AND gates or gates. Okay, there is no interconnection regarding the series of events on the multiple branches of the tree. Okay, so this was just a quick preface. A quick reminder regarding element 3. Let's start or let's hop aboard to see what OSHA mandates regarding the incident investigation. OSHA mandates the following. Number 1, to investigate all incidents and near misses, of course, and to start the investigation as soon as possible, no longer than 48 hours from the occurrence of the event. Okay, so what about the investigation team? At least one person, well acknowledged with process, should be involved or should be present in the accident investigation team. Also, contract employees, if the incident is related to the work of contractors, and at last, other competent personnel with knowledge and experience. Okay. What about the minimum requirements for incident reports? OSHA stated that the minimum requirements of any incident investigation report relevant to process safety should include the following. Number 1 will be the date of the incident. 2 will be the date of the investigation. 3 is the description of the event. 4 factors contributed to the incident, which is also known as the causes, immediate causes, underlying causes, or root causes, and at last, the recommendations. And speaking of recommendations, we should have a follow-up, review, and retention time. A system must be in place for addressing the findings or recommendations with follow-up. There is absolutely no benefit of raising recommendations or recommended actions without the presence of an effective follow-up system. Okay? Moreover, the reports should be retained for at least 5 years. Okay? This was a short element enumerating the incident investigation. I thank you all for your attention and stay tuned for element number 12. Welcome back to element number 12 of OSHA PSM system. This element will address the emergency planning and response. So let's start by defining what OSHA mandates regarding this element. Number 1, to develop and implement an ERP or an emergency response plan. And the ERP should include the event of handling small releases as well. Also, OSHA mandates to develop an exclusive section for the hazardous waste operations in case of loss of primary containment. And regarding the development of ERP, there is a standard that should be adhered with regarding such development, which is the OSHA 1910.38. And regarding the development of the exclusive section of the hazardous waste operations, it should be done in adherence to OSHA 19110.120 sections A, P, and Q. And I will attach these standards in the course reference material. Okay, what about the minimum requirements for ERP? We have here requirements regarding the procedures for reporting of fire or other emergencies. We have also procedures for emergency evacuation and procedures for employees who remain to operate the critical plant operations before they evacuate. We call them the last standing soldiers. Also, OSHA mandates regarding the requirements to have procedures to account for all employees after evacuation. Also, OSHA mandates to have procedures for employees performing rescue or medical duties. And at last, the ERP should contain a contact person details. Moreover, I need to highlight that in the ERP, there should be an alarm system for employees. Okay, and the employer must have and maintain an employee alarm system. This alarm system must use a distinctive signal for each purpose and comply with the requirements. Okay, and at last, I need to state that an effective emergency plan cannot be existing if the employees are not recognizing or not familiar with their duties, and they should also be practicing on drills in order to have a more sense of awareness or regarding the implementation of emergency protocols. I thank you all for your attention. Stay tuned for element number 13. Stop. So hello and welcome to element number 13 of OSHA PSM system. This element will address the compliance audits. So let's start. OSHA mandates that PSM audits should be done every 3 years, and it should be done to ensure that the system is applied properly against the standard. So it will be a critical, systematic examination to all the elements of the PSM standard in order to identify the points of strength and also to identify and highlight the points of weakness, along with the provision of suitable recommendations for rectification and system improvement. Okay? And whenever the report is released and the findings are delivered, the employer should provide appropriate response for rectification of these deficiencies or these weaknesses. And at last, the employers shall retain the last 2 compliance audit reports with them permanently. Okay, that was a very short element regarding the compliance audits. I thank you all for your attention and stay tuned for the last element. So, you have reached the end of the track. Welcome to element number 14 of OSHA PSM system. This element will address the trade secrets. Okay, let's start. The information required for personnel compiling the PSI, including the PHAs, operating procedures, incident investigation reports, ERPs, and audits, should be available without regarding possible trade secret status of such information. And this is done in order to ensure that we will have a healthy and effective output. Because if you blocked from personnel some information that are considered as trade secret, this may compromise the healthy output that the organization needs. But remember, this doesn't mean that such information can go public. Of course, the employer has all the right to sign a confidentiality agreement with parties compiling these data. And the confidentiality agreement will be not to disclose such information considered as trade secrets without permission. And also, this doesn't mean that employees do not have the right to access these information enclosed in the final PHAs. Okay, I believe this is clear. I thank you all for bearing with me on this long trip. Stay tuned because this module is not over yet. So hello and welcome to the second chapter of module number 2 of the OSHA PSM system. This chapter will discuss the interrelations between the discussed OSHA PSM elements. So before we get started, let's first define the critical OSHA PSM elements. As you can see from this graph, there are 7 significant elements. Okay, they are considered the heart and soul of OSHA PSM system. The source of this graph is OSHA NEP, or National Emphasis Program. And for those who do not know what are the National Emphasis Programs, they are temporary programs that focus OSHA's resources on particular hazards and high hazard industries. Okay, the criticality here is based on the number of reported violations. So if we can just zoom in, we will find here that the mechanical integrity is the most critical element of OSHA PSM system. Followed by that, we will have the process safety information, and after this, you will have the operating procedures, process hazard analyses, and management of change, training, and PSSR share equal values. So, respectively, we have the mechanical integrity, number 1, the most critical element. Number 2, we will have the process safety information. Number 3, we will have the operating procedure. Number 4, the process hazard analyses. Number 5, 6, and 7 will be the management of change, training, and PSSR. Okay, so as you can see here, we have this matrix connecting between the critical OSHA PSM elements, which are the PSI, process safety information, PHA, operating procedure, training, PSSR, mechanical integrity, and management of change. These are the critical, and these are all OSHA PSM elements. I'm going to show you the significance of interrelation between these critical elements and all OSHA PSM elements. So let's get started. Okay, Regarding the interrelation between the PSI and the employee or employer participation, we will see that process chemicals, technology, and equipment information should be accessible to all affected personnel. Regarding the interrelation between the PSI with the PHA, we will find that the compilation of written process safety information should be completed before conducting any PHA. Regarding the interrelation between the PSI and the operating procedure, we will find that any updates in the PSI information may lead to a change in the written operating procedures and safe work practices. Regarding the interrelation between the PSI and training, we will find that updating the PSI information may lead to a change in the training contents for plant personnel. Regarding the interrelation of the PSI with the contractors, we will find that any process chemical, technology, and equipment information should be accessible to all affected contractor workers. Regarding the interrelation between the PSI and hot work permit, we will find that the information of process chemicals and equipment involving in process should be accurate and detailed enough to ensure safe hot works. And regarding the interrelation between the PSI and the management of change, we will see, of course, that any change in the PSI must undergo MLC process. Regarding the interrelation between the PSI and ERP, we will find that PSI is referred to construct or develop emergency response plans, so updating the PSI information may lead to a change in the emergency plans or procedures. Regarding the interrelation with compliance audit, we will find, of course, that PSI documentation should be assessed during the auditing phase. And at last, regarding the interrelation with trade secrets, we will find that any related information necessary to generate the PSI should be available for compilation. Okay, moving on to the second critical element, which is the PHA. Regarding its interrelation with the employee or employer participation, we will find that PHA outcomes and resolution of recommendations should be informed to all affected personnel. Also, PHA activities must be conducted by a PHA team with specific expertise. Regarding the interrelation between the PSI and PHA, as you all know, it's a very strong relation. We will see that an up-to-date PSI is vital to conduct PHA, of course, and this is done in order to draw accurate conclusions about the present process hazards and risks. Regarding the interrelation with operating procedures, we will find that identified process hazards should be included in the operating procedures as warnings and cautions. Regarding the interrelation with training, we will find that the content of training module for plant personnel involved in operating the process should include information of identified process hazards from the PHA. Also, the content of training module for maintenance personnel should include information of the identified hazards from PHA as well. Okay? So, regarding the relation with contractors, we will find that, of course, PHA outcomes and resolution of recommendations should be informed to the affected contractor workers. Regarding the interrelation with the mechanical integrity, we will find, of course, that the resolution of recommendations made from PHA may require an update in the inspection, testing, preventive maintenance programs, and many more. Regarding the interrelation with the management of change or MLC, we will find that the MLC documentation is often reviewed during the PHA revalidations in order to determine what changes warrant study during the revalidation. Also, the resolution of recommendations made from PHA may acquire the use of the MLC process. Okay? Okay. Regarding the interrelation with the incident investigation, we will find that reports from previous accidents are reviewed during the PHA revalidations, and also the investigation process for process safety accident may require PHA to be performed as a part of the process. Regarding the interrelation with the ERP or emergency response and planning, we will find that hazard scenarios identified in the PHA should be considered, of course, in the ERP programs. Regarding the interrelation with compliance audits, of course, the PHA information and documentation should be assessed during the auditing phase. And at last, regarding the trade secrets, we will see that any related information should be available to those involved in the development of PHA if necessary. Okay? So, moving on to the third critical element, we have here the operating procedure. Regarding its relation with the employee participation, we will find that written operating procedures should be accessible to all affected personnel to perform their jobs safely, and also the plant operators and maintenance personnel often are the ones who initiate the safe work practices and procedures. Regarding the interrelation with the process safety information, we will find that the knowledge and technical information are used in the development of operating procedures, such as the upper operating limit and lower operating limit and so on. So, this information, of course, must be endorsed in the operating procedure, and also the process safety information should be reflected accurately in any written operating procedure. Regarding the interrelation with the PHA, we will find that
written operating procedures for each operating phase should include steps to avoid the hazards and consequences of deviations identified during the PHA. Regarding the interrelation with the training, we will find that the plant personnel should be trained thoroughly on the content of operating procedures. Regarding the relation with the contractors, we will find that written operating procedures should be accessible to all affected contractor workers. Regarding the interrelation with the hot work permits, we will find that the safe work practices or non-routine procedures must be in place for hot work activities. Of course, they are so close together, they are so interrelated together. Okay, regarding the interrelation with the MLC, we will find that any change in the operating procedures should undergo the MLC process, of course. And regarding the interrelation with incident investigation, we will find that the findings of incident investigation may lead, of course, to a change in the written operating procedure. Regarding the interrelation with the compliance audits, we will find that operating procedure related information and documentation should be assessed during the auditing phase. And at last, regarding the interrelation between the operating procedures and trade secrets, we will find that any related information should be available to those involved in the development of operating procedures if necessary. Okay? So, regarding the fourth element or the fourth critical element, we have the training. Regarding its interrelation with the employee participation or employer participation, we will find that all the plant personnel involved in operating a process of a covered area should be trained in the overview of the process, operating procedures, safety and health hazards, emergency operations, and safe work practices applicable to their job tasks. Moreover, the training materials, training schedule, and training records should be accessible, of course, to all affected plant personnel. And also, the employer should acquire the consultation from plant personnel on the frequency of operational training. Okay, so regarding the interrelation with PSI, we will find that the content of training module for the plant personnel involved in operating the process are developed using the data from the PSI, of course. Regarding the relation with the operating procedure, we will find that the operating procedure should form the technical basis for the training and qualification program of training personnel. Okay, regarding the interrelation with contractors, of course, contractor workers should be trained prior to conducting the work they are hired to do. And regarding the interrelation between training and PSSR, we will find that review and confirmation that training of affected personnel has been completed, of course, prior to the startup of change or a new process. Okay? And regarding the interrelation between the training and incident investigation, we will find that the findings of incident investigation may lead to a change to the training content and increasing the frequency of refreshment training, of course. And also, plant personnel should be trained in the lessons learned from the investigations, of course. And at last, the interrelation between training and compliance audit, we will find that training-related information and documentation should be assessed during the auditing phase. Okay, moving to the fifth critical element, the pre-startup safety review, or PSSR for short. Regarding the interrelation between it and the employee participation, we will find that PSSR information and resolution of recommendations should be accessible to all affected plant personnel, of course. Regarding the interrelation between it and the PSI, we will find that the review and confirmation that construction of the equipment is done in accordance to the design specifications before the startup of a new process. Regarding the interrelation between the PSSR and the PHA, we will find that review and confirmation that PHA has been done for the new process must be established. Moreover, a review and confirmation that recommendations from conducted PHAs has been completed prior to the startup of a change or a new process. Okay? Regarding the interrelation with operating procedures, we will find that review and confirmation that safety, operating, and emergency procedures are in place and adequate, and this should be done prior to the startup, of course. Regarding the interrelation between the PSSR and training, we will find that review and confirmation that training of affected personnel has been completed, of course, prior to the startup of the process. Regarding the interrelation between PSSR and mechanical integrity, we will find that the review and confirmation that maintenance procedures are in place and adequate prior to the startup. Regarding the interrelation between it and MOC, we will find, of course, that review and confirmation that modified process has met the requirements contained in the MOC requirements. And at last, regarding the interrelation between it and the compliance audit, we will find that PSSR information and documentation should be assessed during the auditing phase. Okay. Regarding the mechanical integrity critical element, we will find its interrelation with employee participation as follows. We will see that mechanical integrity procedures, inspection, training, preventive maintenance procedures, and equipment deficiency information should be accessible to all affected plant personnel. Regarding the interrelation of mechanical integrity with PSI, we will find that all inspection, testing, and preventive maintenance procedures and program rely heavily on the data retrieved from the PSI, of course. Regarding the interrelation between the mechanical integrity and PHA, we will find that the results of the PHA will give you the critical equipment or the safety critical equipment that will give you the priority in any MI program, of course. This is very important interrelation sequence between the PHA and MI. The PHA will give you the criticality matrix, or it will give you the criticality of your equipment, and hence the MI program will be modeled and tailored according to the results of the PHA. Regarding the interrelation between it and the operating procedure, we will find that placing the process in the appropriate mode of operation to support maintenance activities require the use of the correct operating procedure. Regarding the interrelation between it and training, we will find that all maintenance personnel involved in maintenance activities of covered area should be trained in the overview of process and maintenance procedures, and also the inspection, testing, preventive maintenance procedures, operating procedures, safety and health procedures, emergency operations, and safe work practices applicable to the job tasks. Regarding the interrelation between the mechanical integrity and contractors, we will find that all MI procedures or inspection, testing, preventive maintenance, and equipment deficiency information should be accessible, of course, to all contractor workers. Regarding the interrelation between the mechanical integrity and PSSR, we will find that verifying equipment under the MI program should be installed according to plan, standards, and so on before startup. Regarding the interrelation between the mechanical integrity and the management of change, we will find that managing the equipment deficiency may require the use of MLC, of course. Regarding the interrelation between the MI and incident investigation, we will find that the findings of incident investigation may lead to a change in the MI program. And regarding the interrelation between the MI and emergency response planning, we will find that equipment relied upon in the emergency response plan should be maintained as a part of the MI program. And at last, regarding the relation with the compliance audit, we will find that MI information and documentation should be assessed during the auditing phase. Okay, moving to the last critical element, which is the MLC. Regarding its interrelation with the employer participation or employee participation, we will find that approved change of process should be notified to all affected personnel prior to startup. Regarding its interrelation with the PSI, we will find that up-to-date PSI is required to support the generation of MLC in order to address the technical soundness of the proposed change and also assess safety and health impact. Moreover, the PSI must be updated accordingly if process change leads to a change in the PSI. Regarding the interrelation between the MLC and PHA, we will find that PHA may be performed to assess the impact of proposed change on process safety. Regarding its interrelation with the operating procedures, we will find that operating procedures must be updated accordingly if process change leads to a change in the operating procedure. Regarding its interrelation with training, we will find that plant personnel should be trained in the process change if the job tasks will be affected by this change prior to the startup of a new process. And regarding its interrelation with the contractors, we will find that contractor workers, of course, should be informed and trained in the change prior to the startup. And this is, of course, very important, as you all know, and it is mandated by OSHA. Regarding the interrelation between the MLC and PSSR, we will find that PSSR recommendations must be resolved before the startup of the change. Regarding the interrelation with mechanical integrity, we will find that maintenance personnel should be trained in the process change if the job tasks will be affected by this change prior to the startup. Okay, and the last interrelation, we will find it between the MLC and compliance audit. We will see that MLC information and documentation should be assessed during the auditing process. So, now we have completed the interrelation matrix. We will find that the PHA and the mechanical integrity are the most interrelated OSHA PSM elements. Of course, as you can see, they are almost interrelated to all OSHA PSM elements. Okay, I hope you all gain the best benefit out of this chapter. See you on chapter 3.